Good morning, everybody. So today is the start of a short week. We're only going till Wednesday this week. We had Thursday and Friday off, so you can be happy about that. You guys have earned it. We've been working really hard in math class, even if even though some of the assignments are short, we're learning something a little new every day. So you need to make sure at this point that you have both parts of your test submitted so I can get you a grade for that. You should have the Google form. You should have that done. You need a Chromebook for it, so if you don't have one, you need to contact me as soon as possible. Um, and then you also need to send me a picture of your short answer questions. So you need to pick 2 out of 3 of those. If you need help on doing any of this stuff, please let me know. I have a video made for it, and I can give you direct help. But we need to get these tests done if you've not done it yet. I assume if you're watching the video, you probably have though. So, anyways, let's get started. So this week since it is short, and it just kind of worked out that 6th and 7th grade we're kind of going over the same topic. So at least for this week. After this week, we're gonna segue off a little bit, but with 7th grade, I'm gonna tie in what we're doing going forward with what we did during the last unit, um, particularly with linear equations. With the 6th grade, we're gonna be going a little bit slower because a lot of this will be new for you guys. Okay, so first off, what even is algebra? You see that written on the screen, and it's probably something you've asked yourself before. Maybe you have some idea of it. Okay? You might have some idea that, well, it's when you start working with these letters. Maybe you've seen me use X before. Maybe if you're in 7th grade, you've been using X and Y. We haven't really talked about what they are or why so much yet. I've kind of shown you in 7th grade, but now we're going to dive into how we're actually going to use variables going forward in math. Not just in my class, but through high school, if you take math in college, through college. So back to the question. What is algebra? That answer, it depends. Depends on your understanding of algebra. My answer, I would tell somebody in college a different answer to this question than I would tell you guys. I would also tell a 2nd grader a different answer than I would tell you guys. And a mathematician, he would probably tell me a different answer than what he would tell another mathematician. Okay, so it depends on what you know. Algebra is a very, very big subject, or a very, very big part of math. When it comes down to it, 6th graders, you can think of algebra simply as this. It's when you work with letters, and the letters represent an unknown missing number, kind of like a blank or a question mark. So instead of blanks or question marks, we're going to use X. Or different letters. All the letters work the same way, but you're going to commonly see X. That's what we're probably going to work with most in 6th grade. Now in 7th grade, algebra, yes, it does involve working with unknowns, X, and you've also seen Y though. So I'd say for 7th graders, for you to understand algebra, I would put it this way: it's the connection between equations, tables, graphs, and ultimately the relationship between different variables, particularly X and Y. As you get more advanced, X, Y, and Z. And as you get more advanced than that, you can take that even further. Okay? I won't get into that, but so let's move on. So right now, let's think of X, Y, letters. They represent some number. Okay, so they follow the same rules as numbers. They are a number. Okay. So what these letters though, we have a math term for it. I know in math sometimes it might feel like English class with all the words, but we do need to know them because it's not just going to be me that uses them. It's not going to be just the IXL. Not going to just be MSTEP, NWEA. These tests are going to use these words, but it's also going to be your math teachers in the future. Okay, and they might not stop and explain this like I am now. So variables, that's what we call these letters, these missing numbers. So generally, we're going to use x for a variable often, but as I said before, you can use different letters. It doesn't matter. Now, a way you can kind of remember variables is if you look at I believe it's the prefix of variables, the var. So vary, if you think of vary, so think of if you ever looked at like an answer key or something, you might have seen answers may vary. That means that there's different answers that are all correct. Okay, so but what matters is that vary means different. There may be different. So vary, think of variables. These are different numbers, right? X could be representing different numbers. We don't know what it is, so it could be there's different possibilities for it. Now, I've done a lot of talking here, but now I think in math it's usually better to show. So I have a little example prepared for you. So what I have here is a real life possible situation. So let's say we have Judy who's trying to save up she's trying to save up to buy some clothes. Okay, but she doesn't know how much she can buy. So she's trying to see how much money she has to spend. Judy has $2 in her pocket, so not so much in her pocket, but she has this piggy bank that she's been saving money in her, for many years, and she knows that there's some money in there, but she doesn't know how much. And then, it's kind of the point of a piggy bank, right? You put money in there, you forget about it, you don't know how much is in there. So she knows she has $2 for sure, and she knows she has some more money, but she doesn't know how much more. She doesn't know how much is in that bank. So this is a perfect situation where we can use something called an algebraic expression. An expression is something that when we use numbers and or variables in math to represent a real situation. So in this case, if we want to write an expression for how much money Judy has altogether, well, then we can take this $2. We know that she's always going to have that $2 in her pocket. And then we can add on however much money is in the bank. But again, we don't know yet. She hasn't cracked open the bank yet. Right? A lot of times you got to break it open so you can really only use it once. It's to keep you from going in it. So if we say this missing amount of money in the bank, or this unknown, this question mark here, is X, well, we can represent how much money she has altogether by the expression 2 plus X. And then we can use this expression if we were able to find out how much money is in the piggy bank. Say Judy goes ahead and cracks open the bank, and let's say she has $5 in the piggy bank. Well, now X is not unknown. We know what it is, right? We opened the bank, so now we know X is 5. So we could do 2 plus 5 instead. And that's what I've written down here. And 2 plus 5, well, she'd have $7 in all. $2 in her pocket plus the $5 in the bank, $7 total. But then you can see, what if X was a different number? Right? It's a variable, right? We said it can vary, it can be different. So what if X was a different number? What if X was something like $100? What if she gets allowance every week? She's saved up a lot of money in her piggy bank, and she counts $100 in there. Well, again, if she counted $100 in her piggy bank, now we know what X is. X is 100. So we can do $2 in her pocket plus the $100 in the piggy bank. And that would tell us that Judy has $102 altogether. So this is a mathematical expression. If it was if she found $10 in the piggy bank, well then it'd be 2 plus 10, $12 altogether. So you can see x can be different numbers, at least with an expression like this. And what we'll get into next week is you're going to see a case when x can only be one number, but in algebra, really what we're building towards is when x can be many different numbers. And that's how the 7th graders are, that's how I'm going to present this to them after this week. We're going to see how x varies and how that changes things, or the result of that. Or if you know what x is, what's y? Things like that. So let's look at some basic examples here that you could see with x. They're not necessarily examples that you need to know how to do yet. They're things we'll cover next week. But let's look at this first one here. This just kind of shows you how a variable works. So in the past, we have this question here, solve for x. And we have 4 plus 6 is equal to x. Now you might already know the answer. It seems there's not much else you can do with this. But what is different is that we have a letter here instead of like a blank or maybe a question mark. You might have seen that in the past. 4 plus 6 is equal to a blank. 4 plus 6 is equal to a question mark. Well, instead of a question mark, we're going to use x, because x is an unknown, just like a question mark or a blank. It's the same thing in this case. So instead of the blank, well, we have 4 plus 6 is 10. Well, just use an x instead. 4 plus 6 is x. 4 plus 6 is 10. So 10 is equal to x. But what about if x is over here? X was all by itself. So that was pretty easy, right? X was just like a blank. And what we're going to see is that's because that's something we want. In the upcoming weeks, we're going to see that we want x by itself. That means you're done. But don't worry about that too much right now. It's just something to keep in mind. For number 2 here, now x is not by itself. Right? Now we have 4 plus x over here on the left. We have it equal to 10. Well, in this case, 4 plus some missing number, some question mark, is equal to 10. Well, if you know your addition, you should know that 4 plus 6 is equal to 10. So in this case, instead of a blank, you'd see we would use an x. X would be equal to 6 in this case. And then there's number 3 here, which next week we'll see goes hand in hand with number 2. There's a reason that we get the same answer. But you see over here, instead we're subtracting, we're still working with 10 and 4. But now we're doing 10, we're taking away this missing number, and that leaves us with 4 left over. So if we subtract some missing number away from 10, and we get 4, well, that means that that missing number we subtracted has to be 6. 10 minus 6 is 4, after all. So this blank, this x, has to be 6. Now, there's some key vocabulary here. I'm going to introduce 3 new words, and then I have some other words that we've talked about in class throughout the year, but words I still think we need to practice, and that we'll need to know for the IXL today. So this first one we talked about already, so I won't spend much time on it. A variable is an unknown. We use letters to represent these. Now, 2 other words, though, expressions and equations. So I've talked about expressions. You know what equations are. You've worked with those. But we didn't talk about how to know the difference between these two, because they are similar, but they're not the same. So you can think of an expression as part of an equation. Right? An expression represents something. right? Like the piggy bank and Judy's money in her pocket, right? How much the expression represented how much money she had altogether. But there was no equal sign. So since there was no equal sign, we call that an expression. In this case, x would be our variable. Or in the second row, we see there's no equal sign, so that's an expression. But in this case, p is the variable. What we see with the blue arrows, that there's equal signs. So we call these equations. But again, we see some different letter, or we see a z for a variable. We see x again. So the difference is pretty easy. If expression, they don't have the equal sign, equations do. An equation that has equal kind of in the name. Now, some other words that we've talked about in class that you're going to need to know. Sum. This is the result of adding 2 or more numbers. So the sum of 2 and 3 would be 5. The sum of 10 and 20 would be 30, and so on. The difference is the result of subtracting 2 numbers. Your difference should generally always be positive, but it kind of depends. So if I asked you the difference between 10 and 7, you would just do 10 minus 7, and that's 3. Just in the order I say it. But there's some other subtraction words you should watch out for, particularly on the IXL. Excuse me. I don't know if it's on the 6th grade, but it is on the 7th grade where they throw in some of these different words like fewer than and less than, and it does make these questions a little tricky. So if we had 6 fewer than z, that means it's actually 6 smaller or 6 less than z. So that means really whatever number this is representing, this expression, well, this number is 6 less than z. So we'd say z minus 6. And then the other way around, if it's z fewer than 6, well, that means that you take away z from 6. 4 less than y, it works in the same way as above. All right, so product here, this is the result of multiplying 2 numbers together. Remember with multiplication, the order doesn't really matter. There's something I'll mention that we'll keep in mind with variables, but we'll get there in a minute. Quotient, this is the result of dividing numbers together. Okay, so in algebra though, instead of this division symbol that you might be comfortable with, we're going to start using fractions almost all the time. Okay, the division symbol, I'm going to get away from using it just because you need to get in this habit of recognizing division as fractions. Okay, so 32 divided by 4, well, notice that this 32 goes in the numerator. You can think of the division sign the same as the fraction bar. And then the second number, this 4, goes in the denominator. Okay, so that's the pattern here. 32 over 4, it's the same thing as 8 over 1 or 8. Z divided by P, again, Z goes in the numerator. The division sign is like the fraction bar. You can think of this meaning divided by, so Z divided by P. All right, then exponents, we've talked about this in class, but in the IXL it says when a number is raised to a power, this is pretty straightforward. If you have something like raise 3 to the 2nd power, or commonly people say 3 squared, that would mean that 2 is the exponent, so 3 squared like this would be your answer, and that's the same thing as 3 times 3. Raise x to the 3rd power, again, that's people use cubed for 3rd power. That means 3 is in the exponent, and it means that we're multiplying whatever number's in the base, in this case an x, by itself 3 times. Now I know it's a variable and not a number, but this actually follows the same rules as numbers. So we just do x times x times x. Remember, x is just a number, so it follows the same rules. Alright, some IXL examples, and then I'll wrap up the video. I know it is a long video, and I had some requests for shorter videos, which I will try to do. I know I've been saying that, but I will make an effort to. But today's topic is super important. Um, and honestly, when I do these videos like this, I really want you guys to be treating this like a class session. So it's like, even if it's boring, you just kind of listen, because it'll make everything much easier, and it should make everything, more interesting. Really, if you understand it, it's going to be more interesting. So, write an expression for the operation described below. I did say try this on your own first, but we'll just go right into this one at least. So w times 2, this is the same thing as w multiplied by 2. Now, you could be done right there. You could type in w times 2, just like I have here, and you'd be fine. But what I'm going to ask you guys to do, just to get in the habit of, is rewriting this as 2w like you see here. 7th graders might be familiar with this from the last unit. 6th graders probably not. When you see a 2w like this, you don't see a multiplication sign, but it does mean we're multiplying when you have a number next to a variable like this. They say multiplying. It's basically the automatic, what you automatically do if there's nothing there. You automatically multiply since we see nothing between them. So w times 2, though, we can say it is the same thing as 2 times w. And we already said we can, if multiplication's implied, oops, I'm giving away all the answers. If we said that multiplication is implied, so we just do, so 2 times w, we just don't have to write in the multiplication. We can just write it like this, 2w. Now for the second one, try this on your own. Subtract p from 7. Just be careful here. Read it carefully. Pause the video. Welcome back. So if we're subtracting p from 7, remember you're taking away p from 7. Okay, subtracting this away from this number. So that means that we're doing 7, taking away, subtracting p. Okay? Remember, subtract p just like you read it. Subtract p from 7. It's from 7. It means it needs to go 7 minus p. Be careful with that. It's very easy to get those wrong. I've seen questions like those on the SAT. They trip up high schoolers all the time. So just be careful. Alright, this last one. Raise y to the 6th power. Hopefully that's pretty straightforward. Think about what that would also mean. What would that look like if you expanded that out? So pause the video here. Welcome back. So you probably could see it down here, but this just means that we need to have y with an exponent of 6. So hopefully you knew that meant to write it like this. That would be your final answer, what you would type into IXL. Now I asked you to kind of expand it out. Think about what that would look like. Well, we're multiplying y by itself 6 times, so it would be y times y times y times y times y times y. There's 6 copies of these. We're multiplying y by itself 6 times. Alright. Oh, I guess I have one more. Sorry. So the last one here, divide 6 by u. Go ahead, pause the video. Alright, welcome back. Next time, if I do a video like this again, I'll make sure to make sure to leave more space so that it's more centered. I know it's at the bottom of the screen when I'm asking you to pause it, so sorry about that. Okay, so you should have gotten something like this for your answer. When we're dividing with variables, remember I said that we're getting rid of the old division sign. That's old. We're past that. We graduated from the division sign. You'll see it time to time, but what you're going to see more often than not is a fraction. 6 over u, 6 over u like this is the same thing as 6 divided by u. So this is how you would have to write in your answer. And remember, we're thinking of that bar is divided by, so you can read this off as 6 divided by u. So I'm going to go ahead and post these notes so that you can kind of go through it and work, write down what you need. I suggest copying these notes down into your notebook. You don't have to write everything down word for word, but what you need, what you think will be helpful for you if we end up doing a final test on this, so which I plan on doing. So that's all I have for you guys today. Again, sorry about the long video, but it's an important topic and it's a short week. So yeah, just wanted to make sure I got this out. We got started off on this unit right. Thank you. Take care.